you can't throw shade on, can't throw shade on, no, you can't throw shade on the corn. Big finish, shade on the corn.
Hi, my name's Parrish. I'm the Research and Education Center Director for the Crop Science Department. And I'd like to give you a little history and background on one of our chief legacies here on campus. Before Red Grange and Dick Buckus ever stepped foot on the field, we had Manly Miles and George Morrow out in these fields. And what are these fields? These are the Morrow Plots. They originally started in 1876 as a rotational study. They were it was understood that our prairie soils were so fertile that they would never be fertilized. Well, eventually they realized that was not the case. More on that later. And so one thing you might be wondering is, what happened to these plots and how they've changed over time? Well, first, these plots were originally measured in rods. They were 16 rods by 5 rods, which is about a half acre for each of these plots. And I'm actually standing in the original 6 plot. So if you look down this line here, you'll see the original outer border of these plots. And if we look down there, we'll see how far they extended.
Here are a few of the maps that show these changes. Now let's head inside the plots. A lot of work goes into preparing for the Morrow plot planting every year. So we'll use the grain yields from the previous year in order to calculate our grain nutrient takeoff and then fertilize accordingly. If it's not a soil testing year, then what we'll do is, of course, work those nutrients into the soil and then just wait for the right date to plant.
So this year, we had, of course, corn planted in plot 3, which is our continuous corn plot. And plot 4 is soybeans. And in plot 5, we planted alfalfa. Our manure off here to my right, and a standard fertilizer off to my left. So all the plots on the west side of the plots are fertilized with synthetic fertilizers that you pick up your local co-op, and then on the right side, on the east side, we have used manure as our primary fertilizer. And we do lime those fertility treatments as needed to reach the desired pH. Now, this is a really big year of preparation for when all the plots are in corn. So this fall, we'll be applying manure, which will be that sweet aroma of research all the undergrads get to enjoy. When we look at the soil fertility of these Morrow plots that have been in production for over 140 years, the soil organic matter is one of those indications of the importance of rotation. When we look at the 0 nitrogen plot and the continuous corn, our soil organic matter averages 3.2%. In the manure plots, it is 3.8%, and in the standard fertilizer, it's 3.7%. In plot 4, which is the corn soybean plots, we average 3.7% in the 0 fertility plots, 3.8% in the standard plots, and 4.5% in the manure plots. When we go to the 3 rotation plot, which is at the 0 rate, 4.6%. In the standard fertilizer, it is also 4.6%, and in the manure, it's 5.5%. So we can see how the importance of applying manure is to improving soil organic matter. But also one of these things that we see with especially the 3 rotation is the addition of rotations in allowing for different root growth and plant growth, especially with the alfalfa being planted or being allowed to grow for almost a year and a half. That allows for that soil organic matter to build over time.
Now that I've covered a little bit about our rotations and soil fertility and these plots, next question you might be wondering is, how do these plots yield? And so let's dig into some of the historical numbers and take a look at how those have changed over time, and then we'll move into our yields from last year. Now let's dig into the yields a little bit more. So a few things to be aware of on this chart. I've simply just taken the most basic fertility treatments and compared them to the unfertilized treatment. So one point to note is that some of the most of these plots started out as unfertilized plots, and then manure was the primary fertilizer through 1955. And then in 1955, they added synthetic fertilizers along with manure in there. So I've only focused on really the synthetic fertilizer side. There are manure numbers, but the chart would get really confusing. And also thing to note is the changes in genetics. All the corn prior to 1937 was all open pollinated corn. But then after 1937, with hybrid corn being more common, that was introduced in the Morrow Plots. And then also in 1967, soybeans replaced oats. So there is a little bit of a difference in the rotations prior to 1967. But I think you can kind of really understand the importance of crop rotation and fertility when you look at this chart. So if you look at this chart over time, when we look at continuous corn plot, plot 3, comparing the unfertilized versus the fertilized plot, the last number of decades, it yields almost a 100 bushel difference between those two plots. And so obviously when you have a high demand crop, the impact of fertilizer is going to be higher there. When we look at plot 4, which has the corn soybean rotation in there versus the fertilizer unfertilized plot, the yield bump between these two treatments isn't nearly as high, which is to be expected because soybeans are supplying fertilizer for the following year crop. And again, with plot 5, where we have alfalfa in there supplying nitrogen, the yield bump isn't nearly as high, yet we do see a drastic difference between both of those two plots in the difference between the unfertilized and fertilizer plots. One thing to note about this chart is I've only focused in on the every 6th year, so there's a lot of data missing in this chart, mainly because this is every 6 years is the only time these plots are all synced up with corn, allowing for some really valuable lessons to be learned, which are really lessons that have been at the heart of the Morrow Plots, and lessons that continue to be reiterated every time we run this. The lessons that we have not changed. Rotations always tend to yield higher than the continuous corn plots, no matter the year, and also the fertilizer plots always out-yield the unfertilizer plots. So the lessons of the Morrow Plots continue to hold true today just as much as they did when they first started. Let's head back into the plots and I'll give you an update on how all the plots yielded last year.
When we look at our yields last year, in plot 3 in the zero nitrogen, we actually averaged zero bushels. Part of this was due to the lack of a proper nick on the zero nitrogen plots. When I was out here, I could tell that the pollen and the silking weren't synced up and therefore didn't have any harvestable yield. In the manure plot, we harvested 42 bushels per acre, and the standard fertilizer was 124 bushels. In plot 4, which is also corn, which is the corn soybean rotation, we averaged 46 bushels in the zero nitrogen plots, 79 bushels in the manure plots, and 156 bushels in the standard plots. In plot 5, which was oats last year, when we harvested those plots, the zero nitrogen plots were 34 bushels per acre. In manure plots, they were 48 bushels per acre, and the standard fertilizer was 75 pounds of N, were 66 bushels per acre. Thank you for taking this time to watch this video. I hope you learned something about the Morrow Plots. Hope you found a new appreciation for them and what they've taught us, and we look forward to having you back here on campus as soon as possible.
When you leave the hallowed halls of Illinois.
like to give this to the alumni. Thank you so much for a wonderful night. This is all thanks to you. Thank you. I would also like to settle the competition and say we're the best three. It's an old established rule of our dear beloved school, and a precept that has brought to children.
Now they're all gonna beat us up after the show!
Brought them joy, and a precept that has brought to children joy.
Well, old Stratford has his bard, and old Harvard has his yard. And on National Championship, who tie knots.
You know how hard it is to tie knots on shoes that do not have laces? Almost impossible.
But whatever you compare, there is nothing quite so fair as our genuine number one home run Morrow Plots. Oh, you can't crochet on the floor. It'll die as sure as you're born. No, sir, we don't mess around. Our library's underground, cause you can't crochet on the cord. Pasadena's got its roses, and the Bible's got a Moses.
Okay, we got 2 monkeys, 2 dragons, some goblins, and IKEA
Wait. Sam, I have some rather unfortunate news. This is the story of Noah's Ark.
No, you know, Moses with the animals and like the IKEA.
I'm afraid you embarrassed yourself, not only in front of a lot of colleagues, but potential soulmates as well.
I'm sorry, I went to public school.
And that Michigan, they're the champions of the West. No, they're not. San Francisco's got its quakes.
Yeah, what are you doing? Earthquake right here.
Yeah, it was right here.
I've been making that one all.
Minnesota's got its lakes.
Minnesota's state drink is milk.
But the Morrow Plots, Illinois are best. Oh, you can't throw shade on the timber. It'll die as sure as you're born. No, sir, we don't mess around. Our library's underground, cause you can't throw shade on the corn. Well, the band is full of drums and California's full of bumps.
Oh my God.
And the whole world's full of smokers trying to quit.
Really? Wow. Loser. They banned you. I'm the loser.
Indiana's full of Hoosiers and Northwestern's full of losers, but the good old Morrow Plots are full of shade on the corn. It'll die as sure as you're born. No, sir, we don't mess around. Our library's underground, cause you can't throw shade on the corn.
Big finish.
Shade